For the last section, I hope you took a stab at merging both the attractor curve and the randomize workflow to create a system where you can run both randomize and use the attractor curve to control the panel types. Well, in this section, we're pretty much going to modify Revit elements and watch the logic stay intact. In fact, we're going to create more elements in Revit, not using Grasshopper, but we're going to modify them using Grasshopper. In a typical project setting, you have people who are um, multiple people are accessing the Revit files and they're doing different things in the files. So what does a collaborative environment look like for someone who's using Grasshopper and someone who's using Revit natively? So to do this, let's apply materials to this um, curtain panel. Okay, so for this solid, we will use actually maybe something we want to do is make these mullions go behind the panels. So let's change the panel offset. Let's see what that does. We make it 1. Winking it right now. Okay. Right, 2. 2.5. Okay, yeah. So now we have our mullions behind the current panels. Okay. And we're going to change the solid panels to some kind of precast concrete. So material, let's set this here, precast. Let's see. Okay. Fantastic. We have precast set here, and something I didn't show is again you can change the types. Okay. So as I change that to straight, and move this, we have the ability to take advantage of that. But we're going to go back to what we had before. Okay. And let's draw a wall in Revit. I'm going to draw a wall. Yeah, a generic wall that is center line. Okay, let's just do this. Something else at center line. Bring this. See what we have in 3D. Okay. So can we modify this wall in Rhino? Yes, we can. What we want to do is query the wall. So we do a query wall. Okay, so here we have it, and now it's asking for the wall system family. So what we want to do is go to input, wall system family, and if you click here, you can see that it's a basic wall generic 8. So it's basic. That's what we want. Our wall here, on the other hand, is a curtain wall. So what we want is a basic wall. We want to get the basic wall. And now you can see that it's brought in those walls in the Rhino area. What I'm going to do is we want to set the height of these walls to match the height of our curtain wall. And to do that, we're going to do set element parameter. Okay, those of you who are familiar with Dynamo, the same thing exists in Dynamo as well. But we're going to essentially take this and then feeding this element in here. But where do we get the parameter key from? What is the parameter key? Well, the parameter key is just like you have here in Revit. This is the parameter, and you have the value. Okay, so it's trying to get what this is. And what we're going to do is inspect element. So maybe we can go to element and go to inspect. Okay, now we click the wall here, then right click. It says, do we want to get all? Let's do get common parameter. Okay, I'm going to move this out of the way. And you can see all. So let me click here. You can see all these basic parameters that we can get from this wall. The cross section, well, it's vertical. Base extension, so that's the base, you know, base offset essentially is here. The top offset, the base extension. I'm assuming this is similar to the base offset. But what we want is the unconnected height. So what we're going to do is connect this value into the parameter key. Okay, so unconnected height to here, and we can remove parameters that are not connected. Okay, so that's something that we can do. And what we want to feed in here is the height of the wall, which is here, 37. So we'll feed that here, and voila. Now we see that this wall lines up perfectly with our current wall. Okay, back. Let's create a camera view, because this is another thing that we can do in, because Revit is allowed to, you know, Grasshopper is pretty much in Revit as a plugin. We're able to modify things in perspective. Dynamo cannot do this. So I will change this here. Let's bring this. You can see all of this modifying. In fact, let's just make this a little bit more dramatic. This here. There we go. Now you can see all of that change get picked up as we go. Well, what if we wanted to create floors in this file? Okay. Now let's get the wall location curve, okay, of this wall. So we have the wall, and I think we can get location curve from the wall. Let's see. We query the wall. Oh, it doesn't give it to us. Let's see. Wall location. There we go. Analyze wall location. Okay, so we connect the wall to this. have the center line, we have the wall location. In this case, we're using the center line anyway. So if we do a merge, okay, so merge this and the driver curve, we want these. Let's see if we can use this curve. Okay, we flatten these so that they're together. Let's use this one instead, because this looks like it's giving us a curve. So you see, this is not a curve as we know it. This is a Revit curve element. So it's an element relative to the Revit API, which is a little bit more advanced. So we'll be using the curve. I think this also gives us a curve exactly. So we can connect this, and then we can join these two. See if it gives us. All right. So we have a curve that we can then use to create the floor. Okay, but before we create floors need levels in Revit. Okay, what we're going to do is create a level. So level, let's go to build, add floors. Okay, that's fine. Input, what we want to do is actually create levels. So levels, this is Revit, we want to add levels. Okay, and to add levels, we need the elevation, we need the type of level, and we need the name of the level, which if we go back to 3D, this is the name of the level, this is the elevation. So level 2 is the name, 10 feet is the elevation, and the type you can see is a quarter head. We have a situation where we have no head, and we can manipulate that in Revit as we go. Okay, I'm going to undo this. So to set our elevations, let us do a domain. We have a floor height that's 37, a wall height that's 37. Let's keep this independent. Okay, so we do a series, panel, and this gives us we want the start of the floor to be 0. We want the floor to floor height to be maybe 10. So we can do 0 to 10. So the way, okay. And we want, how many floors do we want? Well, let's control this as well. Okay, so control, we will divide this by the floor height. Divide this by the floor height, which is 37 here. Get 3.7. Okay, so we want to round down. Round to the floor. Okay, so this gives us 3. So now we have a floor on 0, 10, 20. But what do we do with the rest? Okay, let's keep this as is. So we have height as elevation. Okay, then let's do another series that only has step that is 1. So 0, 1, 2. Okay, that's what's coming from here. Then let's do a format this text such that we want 0. I want this to be working level. Actually, this doesn't need to be in curly brackets. So put this here, and this anything that goes in here is what this 0 stands for. So if we put this here, the data that will come out from here is working level 0, 1, 2. Okay, it's just basic text editing. And now this is going to be our name. So we want to connect this into name. Now we have 3 levels. Okay, but what type? Input, annotation category. Then we have levels here. Then we have element type. Okay, so we can connect that here, and it gives us the type that we want. I remember that these were the 2 that were in Revit. So those 2. So delete that. Move this here. Voila. Now we have. There we go. These levels. Okay, and you see that as we adjust the height, it changes. Okay, so what we're going to do is use these levels here. What we're also going to do is move or copy this curve that is pretty much a floor outline. I'm going to copy in the Z direction relative to these values. Okay, so copy here. Now we have our flow outline. Okay, make those the boundaries. Okay, this is just the type of floor. Okay, that we want to use. So this is model floor type. We can use carpet finish. Okay, connect that there. Boom. Unfortunately, you see what's happening because we're using the driver curve, but the curve that was used to create the curtain wall was approximated to arcs. So maybe what we want to do is join these together. Join. Maybe these arcs, we want to copy them all the way to these, merge them. Yeah, That works. That works. Okay, so we have floors in Revit. We go to 3D views, we see our floors. And as we modify, ooh, okay, floor by floor height, we will make it lower. Yeah, so you can see our floors. So essentially, whatever algorithm we want to use to control our flows, we can embed it in here. I'm going to clean this up just so we can see what is happening here. This. Okay. It's mind-blowing to be able to control Revit elements. As we control our curve, which is here, you should see Grasshopper also do the same controls. Our Revit will then update. Guys, you have succeeded in controlling Revit with Grasshopper. Whether you're working with someone who's adding elements, it works.